Welcome to Earth Science, everybody. Welcome to your final lab of the marking period. And we saved a doozy for last. This one it has some very difficult, heady concepts that we're going to work on. There will be other labs that are busier and like more work, more data. But this one has some really hard ideas. So please, if you're trying to listen to other music or something like that at the time, turn it off. Join me. This is going to be a little sticky. Let's fight through it. I also plan on doing it in a number of short videos rather than one big long one. Um, because I have to switch over to the camera at a couple points too. But follow the steps. You can fight through this thing. And what are we trying to do here? We've got to figure out what is the deal with the path of the sun throughout the sky through the course of the day. All right. You've probably noticed sunrise to sunset and what the sun does throughout the course of the day, right? Now we've got to quantify some of that and really figure out what's going on. So this is a time lapse shot where somebody would have taken a photo every, I don't know how long, every couple of minutes, and then seamed it all together into one to show the sun rising, coming up to its peak, and setting. We did that not quite as artistically on this little thing right here. If you were not here the day that we did this, it's okay. You can still fight through this lab. What we did was we said, instead of a camera looking up at the sky, we said, you live in that little Monopoly house, and these 6 X's here are during my 6 periods that I teach. So periods 2, 3, 4, 7, 8, 9. Okay. I mean, these would really be the same. If you can picture this, you got a big head start on what we're doing. If you say, okay, if I live inside that and I look up at all these X's, it's kind of like this shot right here. If I lived right here and I looked up and saw, I guess there's more on this one, but if I saw 1, 2, 3, 4, 5, 6 X's taking that path, they're the same thing. That's exactly what we're trying to do here. So we've got to figure out, study how the sun travels overhead throughout the course of the day, including 2 things: its path and its rate or speed, if you'd rather say that. And we can do it. And all of that information is sitting right here on this little plastic dome for you to unlock. Let's keep in mind as we do it, the sun is not actually moving over our heads. What's going on? What are we doing? We are rotating underneath the sun. Sorry, these blanks are all a little small. We are rotating underneath the sun. Now, we've talked about this like for weeks now, right? It feels like we're sitting still here. And that's why early humans assumed with the geocentric model, we were sitting still and the sun and everything else was like whipping around us. Now we know heliocentric, sun centered, and the planet is both traveling around once a year and spinning every day to make the sun look like it rises and sets, and to make the moon look like it rises and sets, and to make the stars travel overhead. So, using these globes, we will get both of those things done, remembering the whole time that you live in the little Monopoly house. And the really hard part of this is here's an example of a Regents question, actually, 4 Regents choices. The question's not even on there. Can you, and if you can, again, you're off to a head start, not only say that, okay, Monopoly house, me looking out, that's what this is, but also could you take that and say, here's what those look like when they're printed? Here's what happens when you take a 3-dimensional model and print it on a 2-dimensional piece of paper. That's the challenge, and we'll keep it going. So we'll go on to the next video for the next part. Keep up the hard work. Keep your focus. If you need a break, do it now before you start the next video. This lab can be a doozy. Good luck, folks. We'll see you in a sec.